Остава по-малко от 1 час до началото на следващата лекция.
Няма време.
Точно места са свободни, може да седнете, да. Не се бутайте, моля ви се, отстъпете това място на дамата. Да, благодаря, седнете, седнете.
But with a question from me for you QA professionals.
Question?
Question, yeah.
Oh,
One question for
one?
one t-shirt.
I gonna win a t-shirt now. I think so. Остават по-малко от 7 секунди до началото на следващата лекция. Очакваме ви.
As you see, time is relative.
Заповядайте, дами, заповядайте.
Welcome back. Please take your seats. Clasp your seat belts.
And I think we are ready.
Okay,
For the
welcome
question.
back. I have a question for you.
I have a t-shirt.
What is the most popular QA automation tool? Who was the first? Well, I thought it's the automatic door of your office when you go home. But Selenium is the right answer, so you, sir, win a t-shirt.
But sometimes our Selenium tests are flaky. And that's why we are inviting our next speaker, who is famous in the QA community as the uncle.
Dimitar Topuzov, or Chicho Mitko, as his colleagues call him, has 15 plus years of experience in quality engineering with strong focus on testing web, mobile, desktop and backend systems. He's also a big fan of the Rhodopes and the Audi cars.
He's also one of our nominees for the
QA of the Year award. Make some noise for
Dimitar Topuzov!
Hi all. After this introduction, let me tell you some words about the early days of my career as QA engineer. Back then, test automation was something exotic, and we used Excel tables like this one, where we define test cases with test steps. For each step, we have expected result, we execute everything manually, and then we fill the status if it pass or fail. At that time, flakiness was a known word. A little bit later, Selenium WebDriver was born. Then we also found tools like Jenkins exist. And what we did is we created Jenkins jobs to run our Selenium tests nightly. And how my workday as a QA engineer looked at that point of time, I go into the office in the morning, look at the build status. If it's green, everything is fine. If it's red, then I should investigate what's the reason. And what were the most common reasons for failing builds? It was the issue with product under test, or the test environment, or the test data. Also, it can be an issue with external systems and not enough isolation. It can be a problem with the machine setup, networking, and of course, flaky end-to-end tests. So, what is a flaky test? A flaky test is a test that has non-deterministic outcome. It sometimes passes, another time fails, running against the same version of the product deployed on the same environment. So, what was the impact of those failing nightly builds in Jenkins? So, it decreased the productivity of the QA engineer because each time build is read, QA should spend time to investigate what's the reason. Also, QA should spend time to fix tests or take some other actions to make the build green again. But it was Q-only problem. Developers were not aware what happens, developers were not aware that flakiness exists, and they got contacted only in case real bug is introduced in the product. What changed in recent years is so-called shift-left model, and it says that we should move the testing as early as possible in the life cycle. So, how we work nowadays, we use pull requests for each fix or feature in our product, and on those pull requests we run our end-to-end tests. And what is the impact nowadays? The impact of failing CI/CD is it causes bad emotions. Imagine a developer who is your friend, you drink beers together, he opens a pull request to fix some valid bug, and his pull request is read because you wrote some flaky end-to-end test. So definitely he will not be happy. The other impact is that it also decreases the productivity of the whole team. Not only QA should spend some time to investigate failures, fix tests, but developers will be blocked to merge their work in the main branch, or CD pipeline will be blocked to deploy it on the next environment. The biggest problem is that flakiness become visible to the whole team, and the whole team loses confidence in test automation. On the other side, Selenium is often blamed to be flaky, and even engineers at Google blame it to be flaky, and this is a screenshot from Google testing blog post, which basically says that they observe some flakiness in Selenium tests. So, why this happens? This is a very short Selenium script, which basically starts a new browser, maximize it, navigate to some URL, locate some input element, type something in it, then locate some button, click on it. Finally, we assert that we have 20 results of this search operation, so 20 results are displayed on the page, and quit the browser. So, I have a question here, and this is a question for a t-shirt. So, the first who answer correctly get one. Those are 7 lines of code. How many of them you think can fail, throw an exception, or be some source of flakiness? 7? Who said 7? T-shirt for him. I will ask someone to give him a t-shirt. So yes, basically every line of code here is possible to fail for some reason. And let's start with the first one. We try to start a new browser, Chrome browser instance. So to answer what can go wrong here, we should first understand how Selenium works. So we write our Selenium tests on language of our choice. It can be Java, Python, JavaScript, something else. Our scripts talk to so-called browser drivers, which are separate binary, and this separate binary control the browser. So when we say new Chrome driver, actually what happens under the hood is it looks for Chrome browser available on the machine. It also looks for the Chrome driver is somewhere in the path. And if both are found and versions are compatible, then it will start a new session. Otherwise, it will throw an exception and all of your end-to-end tests will fail. So, a couple of years ago, we found the WebDriver manager of Bonnie Garcia, which is popular in Java world. We also found different WebDriver managers for different ecosystems. We started using them, and initially they looked promising. Because what they do is they try to detect what is the browser version on your machine and try to download the correct driver for this version. And this happens with single line of code, and you don't care about downloading drivers, adding them to the path, such kind of stuff. But the problem are still possible. And what happened is sometimes, even with the perfect implementation of the WebDriver manager, it downloads the wrong version of the driver because sometimes browser vendor release the browser and the driver on different dates. Another case is browser vendor may decide just to move the drivers on different URL, different location, or change the release process, naming, versioning, such kind of stuff. In this case, you need to wait until new version of WebDriver Manager is available that address this issue. You should update the version of the WebDriver Manager in your project and hope that you will be able to start a browser. Finally, we encountered even more issues. So the WebDriver managers are a piece of code in the same way as your end-to-end tests are a piece of code, and in the same way as you write Flaky end-to-end tests, some people write Flaky WebDriver managers. And this is a screenshot from the .NET WebDriver manager. You can guess what's the logic to download Gecko driver, which is the driver for Firefox browser. It gets the HTML source of GitHub releases page, parse the page source with XPath expression to locate the element which holds the version, then get the version as number and try to download this version of the driver. And can you guess what? If you use this WebDriver manager, your Firefox test will fail every time when GitHub release new pages with styling changes. So this moment I just told myself you should stop using WebDriver managers. And here are my tips how to make starting new Chrome driver stable. So the first tip, do not use machines where browser is updated automatically. By default on Windows, Chrome browser is updated automatically each time when you start, and if new version is available, it automatically will get downloaded and installed. So my tip is, do not use Windows on CI, or at least find some way to disable automatic browser updates. Also, do not use WebDriver managers. Make it DevOps problem. Use machines where the browser and the driver are fixed version and they are already installed. In other words, run in containers, some Docker images, or use cloud vendors. And at the bottom there is link which demonstrates how I do CI on GitHub Actions in Ubuntu container, where driver and the browser are already installed, they are correct versions, and it works without WebDriver managers with zero compatibility problems. So, going to the next line, we try to maximize the browser. Well, this may produce different results on different screens, and that can make your tests work on my machine, failing on CI. So please do not maximize your browser. Instead of it, try to make the browser size deterministic, and you can achieve it with adding arguments to Chrome options. You can set window size property, which will set the pixels. But pixels are also something which is not deterministic. If you run on different displays, you may use Mac with Retina display or some display with non-default DPI size. So to solve this, you can also use argument called force revile scale factor, which will scale only the Chrome browser, not the whole desktop, to default DPI. You can also decide to use headless options, which is pretty useful one, but please note that headless affect the window size and the other option. And I have a lot of code snippets examples with a lot of comment in the code on the link on the bottom. And don't worry, you can read it. Slides will be available shortly after the event. So. The third line, we try to navigate to some URL. Once again, let's explain how Selenium works. So we write our scripts in some language, and our script sends HTTP request to the browser driver, which means that browser driver, it's not mandatory to be on our local machine. It can be on some remote machine, some cloud vendor like BrowserStack or something else. Then the browser instance is started, and in this browser instance, we load some URL which is deployed on some web server. And imagine what happens if you are somewhere in Australia and you write your Selenium tests with Java, and you run on BrowserStack, and maybe BrowserStack starts some browser instance somewhere in America. And maybe in this browser instance, you try to load some URL which is deployed on some machine somewhere in Europe. So even if it succeeds, do not fail. When your browser loads your web page, HTTP request will travel through such network cables on the ocean bottom, and it will make your application respond slowly. So it may cause flakiness in your end-to-end test if you are not careful with weights, and you should be more careful with weights with such kind of infrastructure. It can be even a bigger problem. Imagine what happens when you say driver find element or click some element. Every Selenium command sends HTTP request to driver. And if this driver is somewhere on the other side of the ocean, it will make your Selenium tests very slow. My tips are the closer the URL, the better. Try to keep the product under test and your test in the same network. And even if possible, why not execute your end-to-end test exactly on the machine where the product is deployed. The next line, we try to locate some element, but we got no such element exception. Why this happens? By default, Selenium do not wait for elements to be available before try to interact with them. So you may encounter such an exception. And there are a couple of ways how you can fix it and how you can not fix it, should not fix it. So I still see a lot of people using thread sleeps. And this is something that you should never do because thread sleep will make your test slower. And if your site is on the other side of the ocean, your test, it's possible to be flaky again. The next option is to use Selenium's implicit weights, which are pretty simple way to set a global weight, but this global weight is global for the session and it has too much limitations, so please don't use implicit weights. Explicit weights are pretty good option. They are customizable, extensible. Fluent weights are also a good option if they are available for the language you use, because they are not available in all languages you can use with Selenium. So again, a lot of examples how weights work on the link. The next one, we try to locate the submit button, but is this submit button good locator? Well, I don't know, but I definitely know that some people do the following. They open the browser, open the inspector, right-click, copy selector. And this generates some expressions like this one, and those expressions contain full path from the body to the element. And this is definitely not good locator because it's likely to change every time you have new version of your application. So don't use such kind of locators. The good locator is unique, it's descriptive and unlikely to change. You can test your locators for uniqueness inside browser before you move to code. Because if you use locators that locate multiple elements in browser, it's possible that you interact with the wrong element in your test and this will make your test failing. I encourage you to read the official Selenium documentation. Nowadays it's much better than it was 3 years ago or 5 years ago. There is new Selenium documentation website, so please read it. Also read some CSS and XPath tutorials because it's like the multiplication table in maths. You should know locators like this table. What happens next? We try to click on some element, but are we sure we can really click the element? If we try to click an element, it may result in element not interactable exception, which basically happens when element is available in DOM, but not displayed or not enabled. And you can use, again, explicit weights to wait until element is displayed or clickable before you try to click it. Another thing that can happen if you try to click an element is so-called element click intercepted exception, which usually happens when your element you try to click is behind some other element and it's not clickable, some other element is on top. And my advice here is do not try to fix it. Debug your test, see what's the state of your application, because most likely it's a real problem and most likely your end user also cannot click this element. If you read Stack Overflow, some people will tell you, well, if you can't click it with Selenium, why do not execute JavaScript via driver object? Well, this may work and may click the element, but it will just hide real problems in your application. The next one, you can have issues if you try to click moving elements. And for those moving elements, you can wait until animation is finished. And how you can do it? You can use, again, WebDriver waits. And in WebDriver waits, instead of expected condition, you can use WAMP the functions. And this is such an example. Here, I locate the element, get the rectangle of the element, then do a very small sleep and get the rectangle again. And if those two rectangles are equal, then it means that element is not moving. If those rectangles are different, it means that element is changing its size or location somewhere on the screen. So we can use it to wait until animation finish. What else can go wrong? We looked for some list of results to have 20 items. And you should ask yourself, what will happen if results are ordered dynamically in this list? Maybe like this one. So we have a list of items and they are added one by one, but at the first moment, the number of items is not the one we expect. So what can we do in this case? Expected condition API is rich, and we can wait until expected condition dot number of elements to be some number. But if expected condition API is not enough, we can implement our custom expected conditions. We can also implement waits with lambda functions, like the one with animations. And the last one is we can use some utilities like awaitility, which is pretty popular library in Java world. And what awaitility do is it gives you the chance to define Boolean function, and then you can await given amount of time this Boolean function to return true. In this example, I click a button which should export some Excel file, so browser should download Excel file. And with this method, I wait until file is available on the file system. So another Selenium example. We locate some search button, click it, everything is fine at this point. We do something else, and a couple of lines later, we try to click the same button we located on the first line. And what we have is stale element reference exception, which says that element is not attached to page document. And you wonder what happens. Open the browser, test your locator in browser, you see that such element is available in the browser. But what happens here, and the reason for this exception and this failure is that somewhere between two attempts to click the button, the DOM refreshed, the page refreshed, and we try to click a reference to element which is not longer there. So if you receive stale element reference exception, my advice is write your test in such a way that you do not keep reference to elements. Always locate them again before try to interact with them. Or you should also be mindful for such kind of exception, because it's also possible that this kind of exception is bug in your product. Imagine your site refresh, but it should not refresh. This refresh may make it slow, may cause some flickering, bad user experience. So sometimes stale element reference exception is actually a bug in your product. It's always a bug, but you should decide if it's in the product or in the tests. Let's talk a little bit about end-to-end test workflows. So here is a simple workflow, and to save some space on the screen, I wrote it in something like Gherkin. So the flow is, when I click on A, and click on B, and click on C, then I should see the effect of C. And this is not a good approach. Imagine what will happen if I click on A and my application go in some wrong state, and I continue with all the operation, don't care what happens with my application. I've got a test failing on the last line, and it will make it hard to debug, hard to understand where is the problem. So my advice is, when you do some operation, always check the state of application after this operation. When you click on A, check what is the effect. You see the effect of A. When you click on B, check you see the effect of B. And to make it even better, even more stable, always wait for everything. When I tell you click on A, I mean wait until A is clickable and then click it. When I tell you check if you see the result of A, then it means wait until you see the result of A, not just check it. So yes, basically wait for absolutely everything. And if you write all those waits in your test directly, it will make them look ugly. And a disclaimer here. No need to make your tests ugly. Those things with waits, it's what should happen as computing operations, but try to keep your test readable. Use some abstractions to hide all of this complexity and keep your test simple and readable. Here, knowledge in design pattern is something that will definitely help you. And you can also leverage some already existing frameworks like Bellatrix, Selenite, WebDriver.io, or something else that will automatically wait for element and it will solve some of the complexity, not necessarily all of the complexity. Finally, some words about visual testing. What are the most common issues with visual testing inside browser? So different browser versions render differently. So when you update the Chrome on your machine, you may have different images and you should replace your baseline. What else happens is the same browser version, same Chrome version deployed on different machine, let's say Windows 10 and Windows 11, will render differently. So you should use same kind of operating system. You may also encounter issues with blinking cursors, animation, anti-aliasing. You can also encounter issues with dynamic content areas that should be ignored from comparison. And here are my tips for visual testing. The first tip, once again, do not execute your test on machine where browser is updated automatically. Control browser updates and your host operating systems. Execute in containers, eventually use some cloud vendors, or run in some in-house Selenium grid or something like that. Headless mode is something that can help your visual test for multiple reasons. Another tips, implement some logic in your image comparison to ignore different areas of your screen. Also, you can implement logic which counts pixels with very small differences in RGB values as same pixels, and this will help you to solve issues with anti-aliasing. What else you can do? You can disable blinking cursors and animations if you execute JavaScript via driver object. You can also wait until animation finished, as we showed a little bit earlier. And you can also make your image comparison function, a Boolean function, and you can retry it with a utility until it returns true or timeout. So fighting flakiness is actually an easy thing if you follow this schema. For every line of code you write, ask yourself, is it deterministic? And if yes, you have no problem. If it's not deterministic, then make it deterministic and you have no problem again. Some resources. In the beginning, I told you that flaky end-to-end tests are only one of the reasons for failing Jenkins jobs. And usually it's the test data or not enough isolation, and maybe some mocking can help you. And the first resource here is the best ever presentation I watched on QA conference, and it addressed exactly this, dependency on external systems and test data. So I encourage you to look at it. Next two bullet points are very good tutorials for WebDriver weights and lookouts. As I said, they are like the multiplication table in maths. You should just know it. Finally is the Flaky test GitHub repository in my account, where you can find a lot more examples with comments in the code for everything I showed today. I'm Topuzov at GitHub, Topuzov at LinkedIn, also Topuzov at Gmail. So you can reach me if you have any problems with flakiness. You can try to isolate to something that you can share publicly. You can post in software quality assurance user group in Facebook, where I give my best to answer on such kind of topics. And yes, I'll be happy to help you. And thank you, and any questions?
We have time for 1 or 2 questions maybe, and more in the break. Do we have questions? There is
question.
one.
Hi, Chicho Mitko.
Hi.
I have a comment about the WebDriver Manager. We had a similar problem in Bellatrix, and a while ago, as you know, I'm involved in the Selenium project, right?
Yes.
So I have a close discussion with one of their lead developers, Diego Molina. Maybe you know him.
Yeah.
While we discussed all of these problems with the WebDriver Manager, and he told me that actually in the next few releases, they will incorporate all of that directly in Selenium, so this will be solved. However, I have another proposition how to solve it. Actually, in Bellatrix, we have something called machine automation, which is actually in a configuration you execute for Linux or Windows. There are tools that basically they can install the proper version of the browser. This is one of the options. And the second one is you can always use tool like Selenium for Docker, and you can execute that on your local machine. And actually, this is how we do it in some of the projects.
Yes, that's my point. I like the second and the last one you taught. So use Dockers or set up correctly your machine before starting the test. So ensure correct fixed browser version, not some random browser version.
And one more thing about the wait for animations. Actually, you can do it with JavaScript. Maybe you can try it so that it's more general, you know?
True.
Thank you. Another questions? Question. There's one.
Okay, thanks. Mitko, sometimes the flakiness is caused by the test data, so could you please share some thoughts about this?
I can give you short answer in one sentence. The only short thing I can give you is a link to this presentation. It's really the best one for me. I watched on QA conference ever, and it addresses exactly this. So we can talk with you later, and I also encourage you to look at the first point in the resources. And maybe t-shirts for Anton and for him.
Thank you. You can find Mr. Chichumitko in the coming break to ask him more questions. Thank you, and your applause for Dimitar Topuzov!
Thank you.
And good luck to the QA of the Year award.